Welcome to the high school exit exam, the mathematics section of www.happynumbers.org. The strand that we're working on is statistics, data analysis, and probability. And today's lesson is going to be on probability problems. Now, on the website, there are already 3 videos that deal with different aspects of probability, and if you have not watched them and you're not familiar with them, I would encourage you strongly to look at those first, because I'll just give a quick overview of probability here, but you'll need a more thorough understanding. But if you have a good understanding, then let's look at the practice problems. But first, just a quick review. The definition: probability is the likelihood that a particular event will take place. It's our best guess or our best bet. Like, what's the probability that the Giants will win the World Series this year? What is the chance that it will rain today? That's a probability question. Another probability question: if I flip a penny 4 times, what is the probability that I'll get 3 heads and just 1 tail? These are all probability statements, probability problems. Now, a little notation information. Probability is always a number between 0 and 1. It's never less than 0, it's never a negative number, and it's never more than 1. It's never more than 1 whole. It's always a number in between. Now, PE stands for the probability of an event. It doesn't make any difference what the event is right now. But the probability of any event, if it is equal to 0, the probability that the event will happen is 0. That means that that event will never happen. So if the probability of something is 0, it will never happen. The probability of an event, if the probability of an event equals 1, that means that that event will occur every time. It will always happen. Now, these two are rare. The probability of an event never happening or that it will always happen. But if, let's say, if the probability of an event is 60%, that means that 60% of the time that event will occur. 60% of the time that event will occur. Now, of course, if the event will occur 60% of the time, the probability of the event will not occur is 40%. Because 60 and 40% would make 100%. So the probability that an event will occur plus the probability that the event will not occur is always 100%. Let's go back here. If the probability of the event will occur is 60%, then the probability that the event will not occur is 40%, and 60% and 40% equal 100%. Or if the probability that an event will occur is 50%, that means that the probability that the event will not occur would be 50% also, and 50% would give you 100. Now, the way we compute the probability of an event, the probability of an event is equal to, it's a fraction, and the bottom part is the total number of possible outcomes. The total number of possible outcomes divided into, or the top part of the fraction, is the desired number of outcomes, or the number of outcomes that we're looking for. Let's look at an example. If I flip a coin, what is the probability that I will get a head? It'll land on heads. Well, let's flip the coin. Okay, now if I flip a coin, I could get a head or I could get a tail. But we're interested in the probability that I get a head. Well, the probability of heads is equal to the total number of outcomes. Well, there are 2 outcomes. I could get a heads or a tails. So the probability is 2 of the total number of outcomes. And on top is the desired number of outcomes. And there's only 1 desired number of outcome because I wanted to get a head. So the probability that I will get a head if I flip a coin is 1 divided by 2, or 1/2. And if I divide 2 into 1, I get 50 hundredths, 0.50. And you know if you've looked at the changing decimals to percents video, that you move the decimal point 2 places to the right and change it into a percent. So the probability that I get a head, if I flip a coin that it lands on heads, is 50%. Which means the probability that it lands on tails would be the same also, 50%. By the way, you should know, first of all, how to do this kind of a division problem, this kind of a long division problem. And there is a video on the video events section that deals with long division. And you should also know with changing decimals to percents, and there is a video on the video events under the decimals that deals with that. So if you're not clear on those, take a look at those videos also. All right, so now let's go to some problems. All right, problem 1. The probability that Hector will select a green marble from a jar of marbles is 0.25 or 25 hundredths, and the probability that he will select a yellow marble is 15 hundredths or 0.15. What is the probability that he will not select a green or a yellow marble? Okay, well, now, let's see what we have here. The probability that he will select a green marble plus the probability that he will select a yellow marble is 0.25 plus 0.15, which would equal, and actually that's not correct, because 0.25 and 0.15 would equal 0.4. Okay, and if you had difficulty, you would just add like so. Now, the probability that he gets a green and the probability that he gets a Y, we know is 0.40. But the question says, what is the probability that he will not select a green or a yellow marble? Well, if the probability that he will select a green or yellow marble is 0.40, then the probability that he will not would be 0.60. Take a look at it like this. The probability that he selects a green and a yellow marble would be 0.40. That would be, so we have 0.10, 20, 30, 40. So this is the probability that he would select a green or yellow. But this is the probability that he will not select a green and yellow, and there's 10 between each, so it would be 10, 20, 30, 40, 50, 60. So the probability that he will not select a green or yellow marble would be 0.60, and if we look at our answers, it would be 0.6, because 0.6 is the same as 0.60. It's a little tricky question here. This is a little tricky because they're asking you, what is the probability that he will not select a green or yellow marble? So what you have to do is you have to first add up and get the probability that he will select a green or yellow, and that is 0.40. And then you know that if the probability that he did select green or yellow is 0.40, that the probability that he would not would be 0.60 or 0.6, because 0.40 and 0.60 would give you 100 or 1 whole. All right, let's take a look at a different one. Vic and Deirdre are preparing to play a board game. By the way, I've mentioned this to you many times. I hope I have. Don't get caught up on names when you're trying to read this. You can substitute any names. If I come to a name that I don't know how to pronounce or it's difficult, I just put my own name in. The names are irrelevant. Vic and Deirdre are preparing to play a board game. They are choosing a game piece from 3 red, 2 yellow, and 2 blue pieces. If Vic reaches into the box without looking and gets a yellow game piece, what is the probability that Deirdre, without looking, will also get a yellow game piece? Well, let's take a look. I always like to draw a diagram, okay? Because it helps me, and it helps me visualize the problem. So, it says here, they're choosing game pieces from 3 red, so I put 3 red here, 2 blue, and 2 yellow. And so there are 1, 2, 3, 4, 5, 6, there are 7 game pieces altogether. Now it says Vic reaches into the box and without looking and gets a yellow game piece. So Vic picks yellow. Okay, now the yellow piece is gone, so now there are 6 game pieces left. And the question asks us, what is the probability that Deirdre, without looking, will also get a yellow game piece? Well, the probability of getting yellow is a fraction, and the bottom part of the fraction is the total number of possible outcomes. Well, there are 6 pieces that are left, so the total number of possible outcomes is 6. And the top part of the fraction is the number of desired outcomes. Well, they're asking us, what is the probability that she will get yellow? And there's only 1 yellow, so 1 would be the number of desired outcomes. So the correct answer would be 1/6 or choice B. Good. Let's try another one. Mrs. Albert is choosing between white, almond, and gray paint for her garage. She must also choose one of 3 styles of new garage doors. The table shows all possible choices of 1 paint color and 1 door color. Well, here we have white, almond, and gray. Those are the colors. And style 1 and style 2. Whoops, this should be style 3, I think, here. And they want to know what is, the table shows all possible choices of paint color. If she chooses one of these pairs of choices at random, what is the probability that it will be the almond paint color with door style 3? So this would be door style 3 down here, and this would be the almond right here. Let's take a look at the solution. Okay, so the probability that she will choose an almond paint color and door style 3 is equal to the total number of possible outcomes. That's the bottom part. Well, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 9 total possible outcomes over the number of desired outcomes, and the number of desired outcomes is almond color and door style 3. So there's only 1 possible outcome. So 1/9. So the choice would be A. Again, total number of possible outcomes divided into the number of desired outcomes. We have 9 total outcomes. That's our bottom part. We have 1 desired outcome. That's our top part. So 1/9. Look, another one. Mr. Alvarez's class of 20 students has fewer boys than girls. Mr. Alvarez wrote the names of the students on cards and placed the cards face down. He randomly chose a student card and asked that student to come to the board and complete one of 5 problems. What is a possible probability that Mr. Alvarez chose a girl? Okay, now, before we even go into this problem, I may have mentioned this to you different times during videos. A lot of times they throw stuff in the problem that's irrelevant, pardon me, and it's not there to confuse you, but don't get confused by it. He asked the student to come to the board and complete one of 5 problems. That has nothing whatsoever to do with this problem. Doesn't matter, it could have been 1 to 100 problems. The thing here, the key piece of information here, is that there are more girls than boys in the class. And what is the probability that he had chosen a girl? This is a tricky little question here. Again, the probability of a girl is the total number of possible outcomes on the bottom and the number of desired outcomes on the top. Now, look at the problem this way. If there were an even number of boys and girls, in other words, there were 20 students, so if there were 10 boys and 10 girls, then the probability that he chose a girl would be 10 over 20, because the total possible outcomes would be 20, and since there were 10 girls, it would be 10 over 20, or it would be 0.50 or 50%. Okay? Now, since there are more girls than boys, let's say there are 11 girls and 9 boys, then the probability would be 11 over 20. The total number of possible outcomes would be 20, but there are 11 girls. There are more girls than boys. And 11 over 20, I figured it out, and it comes out to 55%. Well, since we know from the problem that there are more girls than boys, then the probability is going to have to be more than 50%, because even just one more girl than boy made it 55%. So since we know that there are more boys than girls, then the probability has to be more than 50%. Well, which one of our choices is more than 50%? Well, choice D. Choice D. So here we had to do a little reasoning. We had to work a little bit backwards and do a little reasoning here. Tricky question. Let's try another one. Which chart shows all the possible outcomes when spinning the spinner twice? So I spun this spinner twice. Which one of these, A, B, C, and D, would show all of the possible outcomes that could take place? Well, let's take a look. This says, and this is the first spin, this is the second spin. On the first spin, I could get a 1, and on the second spin, I could get a 1. On the first spin, I could get a 1, and the second spin, I could get a 2. First spin, I could get a 1. Third spin, I could get a 3. And so on. That's how you would read these. Well, let's go through these and see if we can eliminate. Well, first of all, we certainly can eliminate this one because this has 3 spins in it, and the problem doesn't, it's only talking about 2 spins. So this we can cross out immediately. Now here, if I spin 1 and get a 1, and the second time I get a 1, I spin 2, and the second time I get a 2, and I spin 3 second, that makes no sense. Because I could spin a 1, and I could get a 2 on the second spin, and so on. So we can cross these 2 out immediately. Now let's take a look here. First spin I get a 1, second spin I get a 1. First spin I get a 2, second spin I get a 2. First spin I get a 3, second spin I get a 3. First spin I get a 2, second spin I get a 2. First spin I get a 3, second spin I get a 3. First spin I get a 2, second I get a 3, 2 and 3. Well, what about first spin I get a 3? I could get a 3 on my first spin, so this one makes no sense. So we can immediately eliminate this, and this just by thinking about it. And then obviously our choice is A. On the first spin, let's take a look at it here. The first spin I could get a 1. These are the first spins. So I could get a 1 on the first spin, and then I could get a 1, 2, or 3 on the second spin. So that's right here. 1 and a 1, 2, and 3. On the second spin, first spin, I could get a 2. And if I get a 2, I could get a 1, 2, or 3 on the second spin. And that's represented by here, by the data right here. And then on the first spin, I could get a 3, and then I could get a 1, 2, and a 3. So here I get a 3, and a 1, 2, and a 3. So obviously, choice A is our correct answer. Good. Next one. Rona shuffled a deck of cards containing 5 each of the numbers 2, 4, 6, and 7. If Rona randomly selects a 4 from the deck and does not return it, what is the probability that she will select a 4 on her next draw? Okay, so again, I drew a diagram. So I have 5 2s, 5 4s, 5 6s, 5 7s. And on her first one, she selects a 4 and does not put it back. Now the question says, what is the probability that on the next draw she will select a 4? Well, the probability of getting a 4 is equal to the total number of possible outcomes divided into the number of desired outcomes. So what are the number of desired outcomes now? How many desired outcomes are there now? Well, we want her to get a 4, so how many 4s are there? 1, 2, 3, 4. So it should be 4. Good. What are the total possible outcomes now? Well, we have 4, we have 5, 10, 15, 16, 17, 18, 19. So now we have 19. Good. So the probability that she would get a 4 would be total possible outcomes, which is 19, and the desired outcomes, 4. So it would be choice C, 4/19. Try another one. Jason is competing in a 100-meter run with 8 other competitors. Theo, the runner with the best results from the last race, will get the best starting position. The other runners' positions will be randomly selected by computer. What is the probability that Jason will get the least favorable position? The least favorable, that's important. The last position, least favorable. Okay, so I drew a diagram again. I have position 1, 2, 3, 4, 5, 6, 7, 8, 9. Now there's Jason and 8 other competitors, so there are a total of 9 people in runners. Since Jason is competing with 8 others, there are a total of 9. Once Theo has the first position, how many runners are left? Well, once Theo has the first position, there are only 8 runners left. Okay, so Theo is gone. He has the first position. So now we have 1, 2, 3, 4, 5, 6, 7, 8. How many desired outcomes are there? Well, there's one desired outcome, because the desired outcome, although it may not be very desirable, would be the least favorable position, which would be position 9. But there's only one least favorable position. So if we have, and if the total number of possible outcomes is 8, and the most, or the desired outcome is 1, then the probability of getting the least or the last position is the total number of possible outcomes, which is 8. 1, 2, 3, 4, 5, 6, 7, 8. And the number of desired outcomes, or the least favorable position, is 1, so 1/8. So our answer would be choice B. All right, let's try another one. When choosing one disc from a jar of red and green discs, the probability of randomly choosing a red disc is 3/5. If there are 45 red discs in the jar, how many green discs are there in the jar? Now, this is an interesting problem, and it's a tricky one also. Let's try our solution. Okay, so the probability of getting a red is number of desired outcomes over total number of outcomes is 3/5. They tell us that. They tell us the probability of getting a red is 3/5, and that there are 45 red discs in the jar. So we have to set up a proportion here. If we know that the true probability was some number over some number that reduced to the fraction 3/5, and we know that 45 was the top number, but we don't know the bottom number. So we set up a proportion, and if you're not familiar with proportions, you should go to happynumbers.org and under video events and go down to where the videos that are on proportion, so that you get an understanding of them. So here we can cross multiply. multiply 3 times x and 5 times 45. So 3 times x equals 5 times 45 equals 3x equals 225. And then solving an equation, we have to divide both sides by 3. And this 3 cancels out, and we get x equals, and 3 divided into 225 is 75. So 75 would be our answer. Another way you could work this problem, another way you could work it would be, just let me get back to my, would be, you could set up this, and you could say, what number could I put here for x? What number could I put here for x? That when I reduced it, it would be 75. My bad. I mean, when I reduced it, it would reduce to 3/5. And 45 75ths would reduce to 3/5. If I divided 45 by 15, I would get 3. And if I divided 75 by 15, I would get 5. This is a difficult problem, pretty tricky. Let's look at this one. The letters in the word rhinoceros are written on cards and shuffled. If Nina selects one of the cards at random, what is the probability, written as a percent, that she will select a vowel? So I'm going to ask you to put your video or DVD, however you're looking, on pause. Try solving this problem, and then turn it back on and we'll look at it. Okay, let's take a look. Again, I drew myself a visual. I spelled out rhinoceros, and I highlighted all of the vowels. Now the question asks, what is the probability, written as a percent, that she will select a vowel? Okay, well, the probability that she'll select a vowel is the total number of possible outcomes, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 divided into the number of desired outcomes, which is a vowel, and there are 1, 2, 3, 4 vowels. So we have 4/10. 4/10, if I divide 10 into 4, I get 40 hundredths. And if I multiply by 100, I get 40%. So it would be choice D. Let's take a look at this one. There are 3 different doors that students may use to enter Kingsborough School. There are 4 different staircases that students may use to reach the 2nd floor. The chart shows all possible routes that students may take to get from outside to the 2nd floor. So this is staircase 1, this is staircase 2, this is staircase 3, staircase 4. This is door 1, door 2, door 3, and door 3. So this particular one is door 1, staircase 1. This is door 1, staircase 2, door 1, staircase 3, and so on. If a student randomly chooses a door to enter the school and a stairway to reach the 2nd floor, what is the probability that he or she will use the 1st or 2nd staircase? Well, okay. So, how many total possibilities are there? Because that's one of the things we're going to need to know. Well, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 total. And what are our desired outcomes? That they will use staircase, the 1st or 2nd staircase. It would be this, this, and this, 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 and this. So this would be 1, 2, 3, 4, 5, 6. So the probability that staircase 1 or staircase 2 would be the total number of possible outcomes, which is 12, divided into the number of desired outcomes, which is 6, which would give us 6/12, which would reduce to 1/2. Well, cool. Excellent. Well, that's it for probability. Again, there are the 3 videos prior to this one that deals with probability, and if you're having trouble with the concept, please view these. And if you need, as you know, you can always go back and replay these videos and look at them. Thank you very much for your attention. Really good luck on your test.